In today's class, I'll be taking you on a practical on the topic verification of Hooke's law. So we'll read the instruction and follow it as a guide. It says, you're provided with a rotor stand, clamp, bus, meter row, set of slotted weights, and a pointer. Using the diagram as a guide, carry out the instruction. So first, set the apparatus as shown in the diagram. This is the spiral spring, so I'll fix it here. The first instruction says read and record the length of the spiral spring. So I'll go to 6.90. So I'll write 6.90. The next instruction says place a mass of 50 grams on the hanger. Read and record the new length of the spring. So I'll hang this here. I'll measure its new length, 8.20. So I'll write 50.00. So here will be 8.20. Repeat the procedure for four other values of mass: 100, 150, 200, and 250. This is 50. If I add it here, it becomes 100. I will measure the length again. 12.0. So I'll write 100.00. Here will be 12.00. The next is 150. This is 50. If I add it here, it becomes 150. 15.4. So I'll write 150.00. Here I'm going to write 15.40. The next 200, hang it here and measure the length, 19.20. So I'll write 200.00, 19.20. The next is 250 grams. Since this is 200, I'll add this 50 to make it 250. I'll measure the length again, 22.80. So I'll write 250.00, 22.80. Now find E. E stands in for extension. Extension is final length minus initial length. I'll find the value of E. For the first one, it is 8.20 minus 6.90. That will give us 1.300. Next one is 22.80 minus 6.90. That is equal to 15.900. If you look at this, we've completed the table. These are the readings gotten from the instrument. We leave them in 2 decimal places, while the calculated value, we leave them in 3 decimal places. Plot a graph of E on the vertical axis and M on the horizontal axis. So we draw the 2 axes. This is my vertical axis. While this is my horizontal axis. So I'll label my axis. Here is M in gram, while here is E in cm. Having chosen our scale, we'll quickly plot graph 50 against 1.3. Here is 50. Here is 2, so which means the first line is 0.2. So say 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4. So 1.3 is between 1.2 and 1.4. I'll mark my asterisks here. 100 against 5.1. Here is 100. This is 4, 4.2, 4.4, 4.6, 4.8, 5.0, 5.2. So 5.1 is between 5.0 and 5.2. 150 against 8.5, 150. 8, 8.2, 8.4, 8.6. So 8.5 is between 8.6 and 8.4. 200 against 12.3, 200. 12, 12.2, 12.4. So we have 12.3 here. 250 against 15.9. So we have our 15.9 here. 15.90. So we draw our line of best fit. And that's a perfect line of best fit. So the next question says we should calculate slope. To calculate slope, we draw a big right angle triangle from any point of your choice. But you must ensure that it covers 1/3 of the graph sheet. So I'll write here, change in E, change in M. So slope is equal to change in E over change in M. Slope is equal to 0.070. The next is to find B. B is 4 pi s. Pi is 22/7. S is equal to slope. So I will write 4 times 22/7 divided by 0.070. And the value of B is equal to 3.94. The next says, state 2 precautions taken to ensure accurate results. I avoided error due to parallax when taking reading from the meter rule. Number 2 is I noted 0 error on the meter rule. State Hooke's law for elastic material. Hooke's law states that provided that the elastic limit of a material is not exceeded, force applied is direct proportional to extension. We can state it mathematically, which is F equal to K. E, F is force, K is force constant, E is extension. A spring balance is compressed by 0.03 meters. Calculate the energy stored in the spring. If its force constant is 300 Newton per meter, so I will write extension is equal to 0.03 meters. Force constant is equal to 300 Newton per meter. We're asked to find the energy stored, and that is 1/2 K E squared. So we can substitute. Here will be 1/2 times 300 times 0.03 square. This will give us 0.135 joule. If you step, you will get the total score in any practical examination. Please don't forget to share and like this post for others to learn. Bye.